Is this visible, guys? Hmm. Hmm. Uh, Guys, am I audible?
Yes, sir.
Yes,
Yeah.
sir.
So we know atom have three components: electron, proton, and neutron. Proton and neutron form nucleus, and electron is present outside. First is the discovery of electron. You know, J.J. Thomson, class 9. You have read so much about this. Electron was discovered by J.J. Thomson by cathode ray experiment. So what happened in cathode ray? You have same tube like in uh, Halvar's experiment. So um, you have cathode negative charge and anode positive charge, and judging screen to observe the phenomena. So what happened in this case? When you provide current, so electron will move away from the cathode toward the anode, and these cathode rays are basically electron. Right? Pratigya is not there. हाँ प्रतिज्ञा. हाँ प्रतिज्ञा. क्या हुआ? अरे नोट्स कोई रफ पेपर में बना लो. ठीक है. हाँ क्लास के बाद लिख के दे दो. ठीक है.
So,
Okay. हेलो सारा.
yes, sir.
हाँ नथिंग. 8199 860087. हेलो 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 भाई दीपक बोल रहा था. और ये वो ले गया था टू तो हरियाणा पर. तो 20 और कर दिए थे, मैंने पहुंच गए थे क्या? मैं चेक कर ले. आप who left guys? Jordan is not there, right? Am I audible to all?
Yes, sir.
हाँ यार मैंने भेजे हैं. बताऊं टीम? मैं तेरा तो 1 मिनट में तेरा तो स्क्रीन शॉट भेजो. हैं? ना फिर वो तो पहले भी तो उसका टीम आएगी थी. ना 1 मिनट ना 1 मिनट कॉल पर रही है, क्योंकि फिर मैं भी भूल जाऊंगा. हाँ. हेलो. हाँ 11:30 पे. अच्छा वो आए हैं क्या? ठीक है, तो मेरे हिसाब से और पेमेंट आज को नहीं हो सकती. कौन मैं कल ना कर दूंगा. हाँ. सो गाइस, cathode ray, Sarah, what we did so far, we know atom made up of three components: electron, proton, neutron. Electron discovery was possible because of J. Thomson. So he discovered electron. The name of the experiment is cathode ray experiment, which say that if you have a cathode and anode and pass current through it, so what will happen? Electron will move away from the cathode. So, hello, hello, राम राम चाचा जी कर दो उन्हें टाका जुगाड़ नितीश की लाइट रोज का मैं आई इधर ही हाँ अच्छा तो भूल गया होगा फिर ठीक है दादा So guys, cathode ray experiment when we talk about the electron. So cathode ray means electron. So Anvita, if I say ki anode ray, what should be the meaning of this? Anvita, are you there?
Yes, sir.
If I'm saying cathode ray is electron, what will be anode ray?
Yeah, it will be like wait, it will be positive, right?
Yes, positive, so proton.
Proton.
How do we know? Because cathode itself is meaning is negative. Okay. And anode mean itself is positive. Here cathode, it is negative. Here anode, it is positive. So cathode ray means electron movement. चल रहा बुआ चलो तो ठीक है ओके सो कैथोड रे Jordan, am I audible?
My network's bad. I had to rejoin.
It's okay. So in cathode ray are not visible. So Chandana, if it is not visible, how to observe this cathode ray? Zinc sulfide screen. Zinc sulfide screen will glow whenever electron will hit this. That's why we know it is invisible. We can't see the motion of electron, but we can see there is some change on the zinc sulfide screen, which is the indication that there is cathode ray or electron. Understood? Any doubt? Any doubt, guys?
No, sir. No,
So
sir.
it is invisible, and electron being very light particle, extremely light, 9.1 into 10 is to the minus 31 kg. Parindra, what is the mass of electron? Parindra, what is the mass of electron?
9.1
Into
10 the power minus 31
unit
kg.
kg. Correct. So it's negligible mass. That's why move in the straight line. And we know it is negative. More important is electron movement is responsible for current, and current produce heating effect. Make sense? Current produce heating effect. And last thing, and the mostly asked question in the NEET is, in case of cathode ray, charge by mass ratio will remain same for all the gases. Doesn't matter whichever gas you take, helium, neon, argon, any other gas, whichever gas you take, oxygen, nitrogen, the ratio of the charge and mass will remain same. Cathode ray experiment is done. Okay. So what happen if you want to deviate this cathode ray? Sarah, how will it deviate? Cathode ray means
Sir, electron.
electron. And if you want to deviate electron, what should you do?
Sir, electric field.
If you have charge, example, you keep positive charge, then the electron stream will move toward the positive charge, right? So, based on the charge, path of the cathode ray will be decided. Any doubt? It also deviation depend upon the electric field and magnetic field. Ki if you have strong electric field and magnetic field, then it will deviate more. Electric field means what? Charge. Magnetic field means what? Current. Right? Inversely depend upon the mass. It means if there is heavy mass, deviation will be less. Correct. Example, if a stone is moving, if it is very, very heavy, deviation of this stone is really difficult. But if you take a light stone, you can easily change its path. So, cathode ray movement inversely proportional to the mass. There will be no deviation if mass is very, very heavy. Make sense? Like asteroid. Asteroid is very big. So, asteroid will move almost in the straight line. Any doubt, guys? And you have to write all these things. That's why keep on writing.
So I've run out of paper.
You have to manage, Jordan.
I have to hunt for paper somewhere too. Give me like 5-10 minutes, sir.
Okay, sure. So all of you have to write, but if you feel कि I am going too fast and you are not able to write, ask for time. Okay, ask for time because we are saving time through not writing the
So I forgot
theory
to
part.
write. Like I was not writing until now. So can you show?
You have to write now. That's why you can
Yeah,
write
yeah.
fast.
From here itself, you have to start, right?
Yeah, discovery of electron, cathode ray experiment discovered by J. J. Thomson. What is the meaning of cathode ray?
So what is E and B again?
Electric field and magnetic field.
Done. Sir.
Hmm. Jordan done.
Sir,
Jordan.
sir, just 1 minute, sir. Done, sir.
Yeah. This diagram simply show that key if you have electric field, it will deviate toward the cathode, upward direction. If you have only magnetic field, then it will move in the downward direction, deviation. But if both are equal, then path will be straight line. This path will be straight line. In case of electric field and magnetic field, it's same. If there is electric field means positive charge. It will move toward the negative cathode. Okay. And if it is magnetic field, current is because of the electron, right? Negative. So then it will be downward direction, opposite direction. Understood? Then charge of electron. There was an experiment, Millikan eardrop experiment. Eardrop, oil drop, oil drop experiment. So when you take a drop of oil, it contains mass as well as charge. What will be the amount of charge? Quantization of charge. Sarah, what is quantization of charge?
Sir, it's produced in discrete amount. Q is equal to
Discrete
NE.
amount means what?
The energy.
Discrete amount of energy. What is the meaning of discrete amount? Quantization of charge means if you take charge of any system, then it will be multiple of the integral number, one positive number and whole number. That's why we wrote Q is equal to plus minus NE. E value is fixed, 1.6 into 10 raised to power minus 19 coulomb. N is the number of charge particles, electron. And this N value will be whole number. It cannot be in fraction. This N value will be whole number and it will be positive as well. Because whenever any number exists, it is always positive. Correct? Positive integer. Understood? Any doubt, guys? How Millikan oil drop experiment explain what is the charge on electron? It was minus 1.6 into 10 raised to power minus 19 coulomb. And according to this, what is the charge on any system is charge on one electron and multiply with total number of electrons. Okay. Then discovery of proton. Uh, we call cathode ray as the electron. So anode ray will be positive, and these anode ray are also known as canal ray. Movement in the long tube. And Barinder, we know that electron move toward the anode. Like what will be the direction of the proton movement?
Towards cathode.
Towards the cathode. That's why because anode ray have positive charge. So this positive charge it will move toward the negative charge. Almost like the electron, protons are also invisible. Proton also move in the straight line because ultimately very light particle. Charge is positive, but this is different. In case of electron, charge by mass ratio remains same and it does not depend upon the nature of gas. It will remain same. But if you say anode ray or canal ray, then it will depend upon the nature of gas. If you change the gas, then you will see E by M ratio will also different. Why? Who will tell me? Pratigya, why? Pratigya, are you there?
So,
बताओ, why EM E by M ratio change in case of uh, proton, not in electron?
what time is
Because atomic number of every gas is different. If every gas atomic number is different, then their Z value is different. Their number of proton is also different. Understood? Any doubt? Any doubt, guys?
So can you just explain like how electron mass ratio depends on the nature of the gas for protons?
Because if there is a different nature of gas, it means atomic number is different. That's why you have different gas. If atomic number is same, then it means same gas. And if atomic number is different, it means your number of proton will be different. Because atomic number is
So
equal to number of proton. So it means charge will
okay,
be different.
okay, so now it makes sense. Yeah,
Any doubt?
no, sir.
Hmm. When it comes to the neutron, then what will happen in case of neutron? You have to bombard with the special atom of beryllium. When beryllium atom is bombarded with alpha particle, Anvita, what happened in the Rutherford model based on your understanding?
Sir, could you repeat the question?
What happened in the Rutherford model?
Oh, so like some of the like most of the particles, like they pass through it, the foil, and like only few of them, like very less amount of them, like bounce back like completely.
Exactly. So you take gold foil and then you bombard alpha particle in the Rutherford model, right?
Yes, sir.
Correct.
Yeah.
Here we take same alpha particle but with beryllium atom. And James Sedgwick was the person who explained and discovered the neutron. Okay. So if it is asked you who discovered electron, Thomson. Proton, and this guy, Rutherford. Neutron, James Sedgwick. Any doubt? Any doubt, guys?
No, sir.
Uh, Come to the atomic model. As of now, we just said ki, okay, there is the discovery by this scientist. Now it come to the different type of model. What was the model given by the Thomson and Rutherford? Because in our syllabus we have mainly these two models.
So Thomson gave the plum pudding model, and Rutherford gave like the I forgot the term.
Gold
Planetary
foil experiment,
gold foil. Yes,
planetary
sir.
motion of
Planetary motion.
electron,
Yes, sir.
but gold foil experiment.
Yes, sir.
So Thomson said ki it is plum pudding model example. If you take watermelon, seeds are like electrons and remaining part will be like proton. So you have positives here and electron are embedded in this. Okay. Same like how in case of watermelon, seeds are present according to the Thomson. Thomson said ki atom is neutral and radius of the atom is 10 raised to power minus 10 meter. Sandana, what is the radius of the nucleus?
So 10 power minus 15.
10 raised to power minus 15. Very small, extremely small. So you can compare like you have a cricket ball kept in the cricket stadium. Stadium is so big and this cricket ball is very small. So cricket ball is like nucleus. Full stadium is like atom. So overall atom size is way big than the nucleus. Right? A comparison is important. So when we take cathode ray electron, usually you consider heavy metal. Jordan, why?
So because like you can easily give out electrons.
Yes, because Heavy metal can easily give off electron. Light metal has small size, so electrons are strongly bound. Make sense? Even in the radioactivity, you must have heard the Ron explain the X-ray. Correct? So Ron is the guy who explains the X-ray. This is very basic but still important, even it is given in the atom and nuclei chapter. In case of radioactivity, if there is a breakdown of the atom, who will tell me? Sarah, why elements show radioactivity?
Sir, because the
Sarah,
nuclei are unstable.
nuclei is unstable. How nuclei is unstable?
So the protons and neutrons are like not equal.
So what is how is the imbalance?
Sir, imbalance in like protons and neutrons.
Uh, yeah, proton like which one is more usually?
So could you repeat?
Which one is more, proton or neutron?
The protons.
Usually neutron is more. Anvita, can you give me some example?
Example of?
Like imbalance of proton and neutron. Example of imbalance of proton and neutron.
So like I didn't understand. Like example as in
Element where you have imbalance of proton and electron.
Sir, radioactive elements like uranium.
Heavy element have imbalance, but even you can consider the lighter element can also have imbalance.
so I thought that
Example,
radioactive like elements can
yeah,
have
in I'm talking about
imbalance.
radioactivity only. I'll give you example. Like if you take hydrogen, in case of hydrogen, what is the number of proton? One, correct? Number of neutron, zero. That's why atomic mass is one. Any
Yeah.
doubt?
No, sir.
Now, compare with the deuterium. Varinder, what will be the number of proton in deuterium?
So one.
Yes, number of proton is one, number of neutron is one. Total atomic mass, two. Correct? Correct? So, what happened in this case? There is a balance of number of proton and neutron. Then, Chandana, what is the number of neutron in case of tritium?
So neutron,
Yes. Number of neutron in case of tritium.
3, sir.
No, no, total mass is three, but number of neutron will be two.
2.
Because what is the mass? Total number of proton and neutron, right? Okay. Let me tell
Yes,
you
sir.
this basic thing, right? All of you know atomic mass and atomic number.
Yes, sir.
Yes, sir.
So atomic mass is number of proton and neutron,
One, yes, sir.
correct? Atomic number is number of proton only. When I am talking about tritium, so you have to keep writing what I am saying because what is not given in the PDF, I will ask more than that. That's why you have to write what I'm saying. Proton, protium, deuterium, and tritium. Okay. Protium, deuterium, and tritium. So what happened in protium? Number of proton 1, number of neutron 0. What happened in deuterium? Number of neutron and proton is 1 1. So balance. But if you take in tritium, number of neutron is double compared to the proton. So what will happen in this imbalance? Jordan,
So could you repeat the question again?
what will happen in this imbalance?
It'll tend to break down.
Hmm. It will try to break. That's why you will see, guys, tritium is radioactive. Correct? Tritium is radioactive. What is the reason? Imbalance of proton and neutron. Any doubt?
बस आपका तो कर दिया सही है बस बस
Any doubt?
No, sir.
No,
Yeah.
sir.
So you can take example of this carbon. What happened in case of carbon, Pratigya? Pratigya, what happened in case of carbon, different isotope? Like Pratigya, are you there? Pratigya, no, excuse me. Brinder, what happened in case of carbon? Brinder,
Yes, sir.
no. What happened in case of carbon in when it comes to the radioactivity? Carbon
Subatomic.
12 isotope is normal, but carbon 14 isotope is radioactive. Why? Because in 14 there is imbalance of proton and neutron. I am teaching this from the reference of the your chapter atom and nuclei also. This is not written here, but I will add this example. If you take H1 1, H1 2, and H1 3, this is protium. This is deuterium, and this one is tritium. Due to imbalance of the proton and neutron, it will be radioactive. Only third one. Correct? So we said that radioactivity is because of the imbalance. It could be threefold: alpha, beta, and gamma. If you say alpha ray, it means helium like atom will be produced. Helium like, not exactly helium. Never consider this as helium. Okay, never consider this as helium. Tara, why? Why, when I'm saying alpha particle, this alpha particle will have atomic number 2, atomic mass 4. But how it is different from the helium? Sarah, number of electron, because number of proton and atomic mass, atomic number is same, but number of electron in case of alpha particle will be 2. Correct? But if number of alpha particle is 2, Jordan, then even helium have 2 electrons. So what is this special about this? Jordan.
So I'm not sure.
So tell me what is the number of proton, electron, and neutron in case of helium?
So the number of protons in helium is 2, number of electrons in helium is also 2, and neutrons also 2.
Electron, proton, neutron, everything is 2.
Yes, sir.
Yeah, correct. So that's the difference. If you see alpha, and if you see helium, you know helium also have atomic number 2 and atomic mass 4. Alpha also have same thing. Correct? Then what is the difference in these two? Remember, alpha particle have 2 proton and 2 neutron, but electron are not there. That's why alpha particle is like helium 2 positive. Did I say different thing
Alpha.
earlier? Guys, did I say different thing earlier? Yes or no?
No, sir.
Yeah, then it is perfect. So alpha particle have no electron, but helium have 2 electrons. Helium have 2 electrons. Here, no electron. Any doubt? This is the biggest difference. That's why I was dealing with one question, PYQ, and there I saw the same stuff. Ki what is the difference between the alpha particle and helium? Though, according to atomic number and atomic mass, it look like helium, but difference is it does not have proton. Based on this, Chandana, can you tell me any more difference just based on this data?
So between
Alpha and helium.
and particle and helium.
Yes. Helium have 2 positive charge. Sorry, helium does not have any charge, neutral, because number of proton and electron are same. But in alpha particle, because there is no electron, that's why it is 2 point. And alpha particle is unstable. Any doubt, guys? When it comes to the beta ray, we actually have 2 type of beta positive and negative. But if we are not mentioning what is the meaning of beta ray, you have to always consider electron. Okay? Because if it is beta positive, then positron is produced instead of electron. Understood? Anvita, what is the meaning of this maximum specific charge?
I don't know, sir.
Answer is this specific charge meaning is specific charge if you calculate, it will be the ratio of the charge and mass. Example, if you take alpha particle, charge is 2, mass is 4, charge is 2, mass is 4. That's why specific charge value will be 1 by 2, 2 by 4, 1 by 2. But here, both are 1, 1, charge by mass. That's why this value is maximum, minimum in case of alpha particle. Makes sense, guys? Any doubt? Anvita?
No, sir.
Gamma ray have no charge, no mass. No charge, no mass. Most harmful because maximum penetration. Maximum penetration. Understood? This is very important for your this atom and nuclei also. Maximum penetration. That's why gamma rays are more dangerous because they can penetrate deep into the body and can cause harm. Next is the Rutherford planetary model. Alright? Rutherford planetary model. This model says that most of the atom is empty. How do I know? Because if you take a gold and throw uh, alpha particle on this, what will happen? Most of the particle will move in the straight path. Most of the particle will move in the straight path because most of the space is empty. Nucleus is positive charge. How do I know? Because nucleus will reflect your alpha rays. Nucleus will reflect alpha rays. And last, it says that electron revolve around the nucleus. Correct? So these are the three things. By the way, it is not alpha. This is not gamma, alpha. Alpha ray. Right? So this alpha ray experiment tell you what is the distance of closest approach. Whom I should ask. Sandana, what is the distance of closest approach? I explained this kind of thing in your collision chapter. Sandana,
Yes, sir.
what was the special thing I told you in the collision related to the this alpha scattering, alpha
Sorry,
ray
sir, I
scattering?
don't, sir. Sir,
Barindra,
I
what
don't.
I said in collision related to the alpha ray scattering. Jordan,
So do you want me to explain closest approach, distance of
no, no,
closest
no, no, no.
approach?
I want you to tell me. I said one thing in the collision related to the alpha scattering experiment, alpha ray scattering experiment. What is that?
I do not remember.
Okay, Sarah,
Sir, I remember only half an hour.
guys,
Some
I
kinetic
said,
energy
yeah.
uh,
Continue, Sarah.
turns into potential energy. That's all I remember.
What was this special thing related to alpha ray experiment? I said collision can happen even without the physical contact. This is what I said. An example is gamma ray experiment. This distance of closest approach. Okay, collision can happen even without actual physical contact. Without actual physical contact. This is what I said, and I gave example of alpha ray with nucleus. So when alpha rays try to approach nucleus, alpha ray is positive, nucleus is also positive. So when this alpha ray come closer to the nucleus, it will go back. So it is kind of collision without actual collision. Example, this is nucleus. Okay, this is nucleus. And up alpha particle is moving like this and up to here, and then it go back. Okay, so this is alpha ray. What is special about this? This alpha ray is not exactly colliding with the nucleus. There is some gap. This gap is known as distance of closest approach. Okay, this is known as distance of closest approach. And some people write it R naught or different method. You can write it R. So, Jordan, now tell me what is the distance of closest approach? It is the minimum distance from where alpha particle will go back from the nucleus. Yes or no? It is the distance from the nucleus where alpha particle will go back or return back in the presence of nucleus. Yes or no? Jordan. Jordan, are you there? Jordan.
Sorry, isn't there?
Okay, he's not there. So, Sarah, why this distance of closest approach depend upon the atomic number? It simply says means if atomic number is more, then this distance will be more. That is the meaning. Why?
So due to repulsion.
Due to repulsion, because if atomic number is more, Z value is more, then you will say if there will be more number of proton in nucleus. Nucleus will be big, strong, and this nucleus will repel the alpha particle and distance will be more. Make sense, guys?
Yes, sir.
And when it comes to the mass, if you take heavy thing toward the nucleus, then you know heavy thing will go more closer to the nucleus. So distance will be less. If kinetic energy is more, then alpha particle will go close to the nucleus. Make sense? So this distance of closest approach is really important, even in your atom and nuclei chapter. You have Rutherford model there also. That's why I said key after this I will take your these two chapter, dual nature of matter, atom and nuclei chapter. Okay, so if charge is more, then repulsion will be more, so distance will be more. If mass or velocity is high, then particle will go close to the nucleus and close the distance of closest approach will reduce. Okay, you already know radius of the nucleus is -15, atom -10. Atom is almost 1 lakh time bigger than nucleus. Correct? Atom is 1 lakh time bigger than nucleus. Atom volume is billions, trillions time of nucleus. Imagine trillions time of nucleus. That's why I said it is very, very big. Okay. Drawback of Rutherford model. Biggest drawback is if electron is continuously revolving around the nucleus, then it will emit some radiation, its energy will reduce, and ultimately it will fall in the nucleus and it will become unstable. Yes or no, guys? We already did this, we did Planck quantum theory. Photoelectric effect we need to do. Same photoelectric effect we have in our dual nature of matter. Did you finish your notes from the previous topic? I'll finish this photoelectric effect and then we'll be done with the atomic structure. ना बस खत्म करूं. Are you done with all the notes from this part, from model and
No, sir.
discoveries?
One minute.
No.
If it is no, then I will keep like this.
इसकी डैश हो रहा है मैं तो साहब ना क्यों छड़ना मारा इसको सामने कितना सारे कम सर थोड़ा गेट दे माटी लेवल ऑर्डर पे ले ले के काम मतलब कम
Yes, sir, done.
Okay. Done, guys. Done. Everybody. Photoelectric effect. I told you in the morning. I will tell again. Actually, these tend to kinetic energy. Same example I gave you in the morning. कि you give 10 lakh rupees. Just one minute. हेलो. हाँ जी, बहुत बढ़िया. मैम, क्योंकि बात ये कि अभी के लिए मैं क्या बोलते हैं अवेलेबल नहीं और मैं समझ में नहीं आ रहा कि मैं एग्जैक्टली क्या बोलूं. मतलब अभी के लिए मतलब इसको मैं डिले करना चाहता हूँ. हाँ.
और जाएगा तो यार नहीं होगा इधर का पास करा ये पर मैं पड़ा था ना खाने क्यों आई है तो वही आपका कुछ टाइम तक काम करेगा होगा तब तक आपका श्योर है ग्राफ देगा अब ले आएगा बस ये नहीं कर
हम्म. फिर तो मैम उसके लिए संडे को ही करना पड़ेगा. क्या? नहीं, मेरा संडे ही ऑफ रहता है मैम. ठीक है, फिर आज हम क्या बोलते हैं लगभग 10 बजे करते हैं. नहीं, ठीक है मैम, 10 बजे कर दीजिए. 9:30 मुझे एक बार प्लीज कॉल कर दीजिएगा याद दिलाने के लिए. ठीक है मैम, श्योर श्योर. ओके. ठीक. गाइस, so same thing कि you hit light with this energy 10 joule 2 joule energy invested to bring electron out on the surface, and 8 joule energy will be utilized for the movement of electron. In the morning, we did same stuff. Okay, whatever energy a light hit the surface, metallic surface, what will happen? Some will be work convert into the work function, minimum energy. Same work function is also known as the threshold energy. Threshold is the minimum energy you require so electron can come on the surface. Minimum energy. Okay. And once you pay enough energy for uh, to break the electrostatic bond, then electron will start moving. And when electron move, there will be kinetic energy. Anybody have doubt?
No, sir.
So that's why we know our energy will be equal to phi naught kinetic energy. It means if you give whatever energy, some will be utilized in the work function and remaining will convert into the kinetic energy. Jordan is there? No. He have network issue. Okay. So
So,
PEE means photoelectric effect. Yes, Anvita?
so what did you do? I was not there for like 5, 6 minutes.
So I think we were starting photoelectric effect by then, right?
I think, I mean, you were on that page, alpha ray scattering experiment.
Alpha is scattering experiment. What did you miss?
Yeah, I didn't. Okay, yeah, I heard the collision thing.
Okay.
Yeah,
So
but no, I'm not sure.
it's okay. You leave half page for this
Yeah,
and then go through the video and finish this part. Okay. If you don't
only
understand,
half
then let me
page
know. Yeah, for this one.
till
Send me
photoelectric.
remaining send me remaining part and for half page you just go through video because
Yeah,
if
yeah,
I explain now, I'll do it in hurry. Then I
yeah,
did in very with Garam. Okay.
yeah, yeah,
Yeah. So photoelectric effect, if you hit a surface, metal surface with some energy, some of the energy will be invested in the work function, also known as threshold energy. With the remaining energy, electron will move, and that movement will be responsible for the kinetic energy. What we are saying, कि when photoelectric effect will be observed, when photoelectric effect will be observed, situation is if your energy is greater than threshold energy, then photoelectric effect will be there. Correct? Threshold is the minimum energy. Remember, whenever we say threshold energy, it is work function, and function is always minimum energy. If you give minimum example, if worker need to pay 2 lakh rupees, okay, to the owner. If you pay worker like 1.1 lakh rupees, it will be insufficient. You cannot bring out worker from owner because you are supposed to pay minimum 2 lakh rupees. So if you have money more than 2 lakh rupees, then definitely there will be photoelectric effect and definitely we can save worker from Jordan. Right? Correct, Sarah?
Yes, sir.
Jordan is a very bad guy. He is detaining the workers.
No,
Okay,
sir,
so
it's not that bad.
he is not detaining workers.
No, no, sir.
Okay. Next, like whenever next time he'll come, I'll ask him same question. Ki you are a bad guy, you detain worker. Next, if uh, your incident frequency, because frequency is related with the energy, if your frequency is more than the threshold frequency, threshold means minimum frequency you need for minimum frequency you need to bring out the electron is the threshold frequency. So we'll say in this situation, incident frequency will be more than the threshold frequency. Okay. And why wavelength is ulta? Because you know that wavelength is equal to T by nu frequency. When frequency is more, wavelength is less. Understood? That's why you need frequency more than the threshold, but you need wavelength less than the. Understood? Any doubt, guys?
No, sir.
Any doubt? So that's why you know E is equal to H nu. I wrote F. F means frequency only, or I am writing HF, same thing. F means frequency. You know total energy is equal to HF. H Planck constant, F frequency. Work function will be HF naught. What is F naught? Threshold frequency, minimum frequency. And remaining will be responsible for kinetic energy. So what will be kinetic energy? Total energy minus threshold frequency, threshold energy. Why? Because example, we want to know how much money is responsible for the business. What you will say, how much money you have paid, like 10 lakh, how much money you are supposed to pay to remove from bondage, 2 lakh. What is the actual money will be utilized for the business purpose? Only 8 lakh rupees. Makes sense? Same thing here, kinetic energy. Kinetic energy is total energy minus work function. Any doubt?
No, sir.
So this total energy is equal to hc by lambda because we know frequency is equal to c by lambda. This is hc by lambda naught. Understood? Any doubt, guys? Ask your question. Any doubt?
There is a last wala point.
This one?
Yes, sir.
Okay, so in this situation, kinetic energy you know is equal to total energy minus work function, right? Okay, so energy is equal to total energy hc by lambda minus this work function value is hc by lambda naught. So hc is common, it will come out. What will be the remaining value? 1 by lambda minus 1 by lambda. Any doubt? Any doubt, guys?
No, sir.
Kinetic energy is equal to half mv square. What is this graph mean? How we get this? You know your kinetic energy is equal to E minus nu naught. Nu naught is work function. Kinetic energy is equal to E is equal to HF. HF means H into frequency minus HF naught. Correct. If you take this in the form of uh, y is equal to mx plus c graph. So this is the c value, h is m value. Here it is a graph between frequency and kinetic energy. This is kinetic energy, this is frequency, and graph will be h is slope and c value is equal to this minus hf naught. Any doubt? Ask how we drew this graph.
Sir, I didn't understand the graph part.
Okay. Did you understand this equation? Did you understand this equation?
Yes, sir.
Okay. So, according to the graph will tell you what they are asking for. In this situation, graph is asking between the kinetic energy and frequency relation. Kinetic energy and frequency relation. This will be given to you. So, what is your y-axis? Kinetic energy. Kinetic energy. What will be your frequency? It look like x-axis. Correct. What is
Yes.
c? Y-intercept. Here value is minus as if not minus value. That's why negative. And m is the slope. What is the slope value? Let's just compare. This is y-axis. This is h. This is x-axis, and this is the y-intercept value. So you know slope is positive because h value is overall positive. That's why you will draw like this straight line. Why? Because kinetic energy directly depend upon the frequency. So this will be like this. And slope value, m slope value, this is represented by slope. And here slope is equal to what? H. And C, y-intercept value is minus. That's why you will take this one. Okay, minus HF. Any doubt?
No, sir.
Understood? If you
Yes,
like
understood.
in any situation, by chance, if you get same equation like this, kinetic energy is equal to HF plus HF naught. In case, though it is wrong, but if you get and you have to draw graph, then y-axis is F, x-axis sorry, y-axis is kinetic energy, x-axis is F, slope is still H, but now this overall value is positive, so you will draw like this. Slope H and this value now will be positive. Any doubt?
No, sir.
Done. Last point. If you increase the light intensity, like too much light you throw, too much light, what will happen? There are more number of photons. That's why there is more light intensity. Then more electron will come out from the surface. There will be more current because of the electron movement. But remember, there will be no impact on the kinetic energy because kinetic energy does not depend upon the number of photons. It depends upon the quality of light. Remember, when we talk about intensity, it is quantity, number of photon you are throwing. More light you throw, more electron come out of surface. But kinetic energy depend upon quality of light. Like what is the speed of the particle that is hitting the surface? Ask me, guys, your doubt if you did not understand this. Okay. So when you say intensity, if you say intensity, then intensity it means quantity of light. How much light is hitting the surface? And when you say uh, frequency, then you talk about quality of light. Understood? Quality. Like what is the energy of each particle? Energy of each particle is telling you the quality. Number of particle is telling you intensity. Tell me, guys, any doubt?
No, sir.
Okay. And kinetic energy is also equal to the potential energy. That's why kinetic energy is equal to EV naught. What is EV naught? Potential energy. You. This is U, potential energy. Q into V, right? U is equal to Q into V. And with this, we are done with the majority part of the dual nature of matter. 90% of the dual nature of matter is done already. But for dual nature of matter, I will write and we'll solve more graph. We'll discuss many graph in the dual nature of matter, but only one class. One class is more than enough with the question. I'm not saying like only for theory. No, with question. Now I will take only one class of dual nature of matter. Bohr model we did, everything we did. You can solve any question. So it's 3:51 now, and I will take class at 6. Okay, and till then, you what you will do? You solve 50 question, and when I'm saying 50 questions from every topic, from full chapter. Example, from atomic structure, if you have like 4 topics, from every topic you will solve 12 questions because quantum number will be revised, Bohr model will be revised, dual nature of matter will be revised, and this models and everything will be revised. We finished this chapter, we finished atom and nuclei, we finished dual nature. Any doubt? Any doubt, guys?
No, sir.
Okay, so I'm ending this session. Send me your notes. Send me